So we have tangent squared theta times 1 plus cotangent squared theta. There are different approaches for this. So tell me what you did first. Okay, good. You can use your identity, so that is cosecant squared theta. Then I would go to sines and cosines. Tangent is sine squared over cosine squared. Cosecant is 1 over sine squared. When you multiply those, what happens? So we're left with 1 over cosine squared theta, which is secant squared theta. Make sure you're showing all of your work. Your work is your answer on all of these problems. All right, 9b. Tangent of pi over 12. What should I do with that pi over 12 to start with? So we'll multiply by 180 over pi. So that gives me the tangent of 15 degrees. So I need two angles that I know from my unit circle that add or subtract to 15. What would you use? Okay. So now look at your flip chart. Make sure you know how to use your formulas. We are using the tangent difference formula. So that's tangent of the first minus tangent of the second over 1 plus tangent of the first, tangent of the second. Tangent of 45. So you guys have to be able to know these. You know, if you liked, we had tables at one point. If you need a blank table for the test, you can have it. If you need a blank unit circle, you can have it. Or they're really just hand tricks. So as long as you know your hand trick, you're good. So if you fold in 45, tangent is radical 2 over radical 2, which is 1. Tangent of 30 is radical 1 over radical 3. So that's radical 3 over 3 over 1 plus 1 times radical 3 over 3. I have told you that on these I would let you leave the radical on the bottom, but I did ask you to not leave a fraction in a fraction. So easy way to get rid of that is multiply by 3 on top and bottom. Distribute, so we get 3 minus radical 3 over 3 plus radical 3. So okay. Problem 14. So we are into the proofs now. Alright, first step we have to decide which side we're going to plug in. And we know if we get stuck we could always end up working, which side we're going to work on. But we could always work both if we got stuck. Which side did you box in to start with? Okay. Alright, my recommendation, kind of look at what we're going to. All I want are cosines. So this cosine squared, that's fine, but I want to get rid of everything that's not a cosine. So we could, cosine squared x. I really don't want a sine, I want a cosine. What could you change sine squared to? Over. What could I change secant to? So we could distribute this negative. So that gives us a 2 cosine squared x minus 1 divided by 1 over cosine x. How do you divide by a fraction? So that's times cosine x over 1. So if we distribute, we get 2 cosine cubed x minus cosine x over 1, which you don't have to have, and that's all we needed. We're done. So keep your goal in mind. Look at, no, I wouldn't have necessarily known to get rid of my sine squared if I hadn't looked at what I was trying to get. If I hadn't looked and realized that my final answer only needed cosines. So kind of keep that goal in mind. Number 15. Alright, which one do you want to box in here? Right, I agree with that. Okay, so look at where we're going. We want secant of b. When I'm looking at this, I notice right away that I have a sine of 2b. So what should I do with that? Okay, so that's 2 tangent b. So sine 2b, that's a double angle. The formula is 2 sine b cosine b. My 2's drop. What should I do with my tangent? So that's sine b over cosine b all over sine b times cosine b. This is just over 1. So like on the last problem, to divide fractions, we flip and multiply. Make sure your work is easy for me to follow. Okay, don't like work down and then up and all over the place. Make sure I can tell how you get from one step to the next. So if I flip and multiply, what happens? So I have 1 over cosine squared b. Cosine times cosine. And what's the reciprocal of cosine? So that is secant squared b, which is what we wanted. Is that okay with everybody? Number 16. Which side you box in? I agree. It's probably easier to get rid of the fraction than to turn something into one. Look at our goal. We want cosines. So right now I have tangents. What can I change tangent into? Okay. On the bottom, 1 plus tangent squared. So
Yeah.
okay.
And then on the top, I did. Never mind. Just keep going.
Okay. So you can, 1 plus tangent squared is secant squared. There is not a formula that tells us what 1 minus tangent squared is. So what would I need to do at this point? Sines and cosines. Anytime you're set, go to sines and cosines. And if you'd started there at the beginning, that's fine. You would have gotten to the same point eventually. So tangent squared theta would be sine squared theta over cosine squared theta. Secant squared is 1 over cosine squared theta. So we can flip and multiply. Remember another trick I've talked about is if you take top and bottom times the same thing, it's legal. What would I want to multiply by on this one? So the same thing as if we flip and multiply, just another way of writing it. Just showing you another trick here. So if I distribute that, I get cosine squared theta minus sine squared over cosine squared times cosine squared. So those cosines drop. And the bottom just turns into a 1 So that's cosine squared theta minus sine squared theta. Okay. That's cosine 2 theta. Look at where we're going. Do you see how to get there?
Wait, what'd you just do before that?
Here? Or
After cosine squared theta minus sine squared theta.
okay. The denominator just cancels, so it turned into 1. And then
Right.
this was the first double angle formula from yesterday.
Okay.
So that turned into cosine 2 theta. You're welcome. How do I get to where I need to go?
Change it to the other cosine, to the formula.
This is just another of the cosine double angle formulas. So if you're looking at the third formula I gave you yesterday, cosine 2 theta is 2 cosine squared theta minus 1. Those formulas are all equivalent. There's other ways of getting there. You could have changed your sine squared into a 1 minus cosine squared, and you would have got there that way. You could have came and worked this side and changed it to your cosine 2 theta. So, lots of options. Make sure I can follow your work. Any questions on that one? So we're good on 17. You just did the difference formula for sine. Let's look at 18. Alright. What do you want to box in? Remember, I expect to see 2 boxes on every problem that match, so I know where you started and where you ended. If you want to add or subtract fractions, we need, so I'm going to take this one times 1 plus cosine theta on top and bottom. And this one times 1 minus cosine theta on top and bottom. So if we distribute, we get sine theta plus sine theta cosine theta over, if you FOIL on the bottom, that's 1 minus cosine squared theta. Minus the second fraction, if we distribute, that's sine theta cosine theta minus sine theta cosine squared theta over 1 minus cosine squared theta. Have I lost anyone there? From here, the denominators match. What should I do with this negative? Distribute it. I know we had one on a quiz one time like this, and several people forgot to distribute the negative, which caused some problems. Once we do that, we can put these fractions together. So I have a sine theta, cosine theta, and negative sine theta, cosine theta. Those drop. Sine theta, cosine squared theta. Okay, look at where we are going. We don't want the fraction anymore. We need things multiplied. If we get stuck, we can always work the other side. Do you see any options for right now?
I changed the sine theta cosine theta to 1 plus cosine squared theta, but I don't think I can do that. Because only 1 is moved.
Right. What about 1 minus cosine squared theta? What can you change that to?
Sine squared.
Yeah, let's do that. So then what happens?
Can like one of the signs in the bottom cancel?
Yep. We can take a sine out of everything. So that would leave us with a 1 plus cosine squared theta, which if you look at your goal, that's good. We need that. Over sine theta. This step isn't necessary, but it kind of illustrates. If the sine's on the bottom, that's the same as saying 1 over sine times 1 plus cosine squared theta. What is 1 over sine theta? Which is what we wanted. If you hadn't seen how to get there, I would stop right here and go work the other side, and you would get there really quickly because you would change your cosecant into a 1 over sine and distribute it, and it would take you right there.
Okay, so you crossed off the two signs on the top. So then why did you put a sign on the bottom too? Because
Okay. So on the top, you could like pull out a sign, and that leaves you with a 1 plus cosine squared divided by sine squared, which is like saying sine times sine. So one of them cancels, but there's still one left.
so like right next to that where you crossed off both, you didn't really cross off both.
Right. I took, each one out of each term.
Okay.
Other questions?
Could you like break it apart and do the same thing?
Yeah. Are we okay with this one now? Let's look at problem 19. Oops, I left off two. Alright, which side do you want to box in? You boxed in the tangent? Okay. So, what can we do? Okay. And that leaves us with 1 minus cosine squared theta. What's 1 minus cosine squared? So we have 2 sine squared theta. Where do I go from here?
That's where I got stuck.
Okay, so what can we do if we're stuck? Alright, so let's box this in. And let's work the other side and see if we can get to the same thing. Make sure if you work both sides, I can tell that you work both sides, so make some columns for me or something. So, looking at our goal, I only want a sine. So what would I change tangent to? Times sine 2 theta. What would I change that to?
2 sine cosine.
That's just from our formula. What happens there?
The cosines cancel.
So sine theta times 2 sine theta is 2 sine squared theta. And that's what we wanted.
If we do that like on the test, do you want us to like erase the first box?
Yeah, that way I know you weren't still trying to get there and just gave up. Right. Problem 20. Alright.
Can I get a sheet for him?
Yeah. Okay, which side did you box in?
Right.
So on the left, take a look. Our goal, I want all my angles to be A. But on the left, all my angles are 2A. So we need to use double angle formulas to start with. Alright, we have a lot of options for cosine 2A. Look at where we're going. I want a cotangent and a tangent. That involves sine and cosine. So let's pick a formula that involves sine and cosine.
Cosine squared A minus sine squared A.
Oh. Sine 2A, there's only one option. 2 sine A cosine A. What happens first? The 2's cancel. You have two terms on top, so you can break apart your fraction. The denominator goes with both of them. So it's cosine squared A over sine A cosine A minus sine squared A over sine A cosine A. The first fraction, what reduces? So you're left with cosine over sine, which is cotangent. Minus, in this one, we drop out a sine and you have sine over cosine, which is tangent. So if you look at where you're going, it helps a lot. We could have gotten there if we'd used a different formula for the cosine 2A, but this was significantly easier. And again, I knew to use that one because my final answer, I wanted cotangents and tangents. Both of those use sine and cosine. So I picked the formula that had both of those. Questions there? What else do we need to talk about?
Can we do number 12?
Good. 12 and 13, well, 11, 12, 13, these are all kind of like last night's homework. So it's probably good to talk about those. We haven't practiced them as much. I want sine x and cosine x. I know that cosine 2x is negative 3/4. And we are between 0 and 90. So that tells me we are in quadrant 1. So everything should be positive. To find the first one, you really just have to use a formula. And if I only asked you to find one of them, I would just use a formula to do it. Let's say I wanted to find the, I don't know, sine of x. Which formula would you use?
1 minus 2 sine squared.
So we can plug in. Cosine of 2x is negative 3/4 equals 1 minus 2 sine squared x. Subtract our 1. Divide by negative 2. That will give me a positive 7/8. To get rid of a square, we do square root, and with that plus and minus, so that's where your quadrant comes into play. In quadrant 1, we know it should be a positive. So I have the square root of 7 over the square root of 8. We could break that into a 4 and a 2, so it would be 2 radical 2. Get the radical off the bottom. So on the bottom you have 2 times the square root of 4, so 2 times 2 is 4.
I have a question on that.
Yes.
So you split apart the 8
Mhm.
first, but like on the homework I did 7 times 8 and like got it off the bottom first. Is it gonna be
Yep, you'll just reduce later. To get cosine x, we have two options now. Since that's the only other one I asked for, we could use the other formula and solve it just like this one. Or, since I've gotten the first one, I could set up a triangle to get the second one. Either way. Which way do you guys want me to do it?
Can we do triangle?
Yep. So you have to draw it in the appropriate quadrant. So we're in quadrant 1, so that's my theta. Sine is opposite over hypotenuse. So we need to find our missing side. A squared plus radical 14 squared equals 4 squared. Again, square root, you would do plus and minus, but because we're in quadrant 1, it is a positive radical 2 for this third side. So then cosine x, so Gatoa, cosine is adjacent over hypotenuse, so radical 2 over 4. So you have to use an identity for the first one. Second one, you can either use the identity or do the triangle.
So when you're doing your quadrants,
Mhm.
how do you know that it was in the first one?
The problem said it fell between 0 and 90.
Oh, okay, so if it was like between 0 and 180, it would be second.
Between 90 and 180, yeah, would be second.
Oh.
Okay, we've got 5 minutes. What else? 13. Okay. So, we want sine and cosine of 2x. Sine 2x, looking at your formula, there's only one. That's 2 sine x cosine x. In the problem, I gave you cosine x. We don't know sine x, so how am I going to get it? Triangle. It tells us, let's see, sine is greater than 0. So all students, that's 1 or 2, and the value of cosine I gave you is greater than 0. So what quadrant am I in again? Quadrant 1. Okay. So there's my angle. My cosine is adjacent over hypotenuse. So I'm going to find my other side. Will it be a positive or a negative?
Positive.
So we get 3 plus b squared equals 25. So b squared equals 22. Square root, plus and minus, but it's positive, and 22 does not break down. So it's just the square root of 22. So sine, opposite over hypotenuse, is radical 22 over 5. So then if you multiply the tops, multiply the numbers under the radical together. So it's 2 radical 66 over 5 times 5 is 25. 66 doesn't have any perfect squares in it, so that's it. So cosine 2x, you have 3 formulas, pick one. What?
1 minus 2 sine.
Okay. So 1 minus 2 sine was radical 22 over 5 squared. Radical 22 squared is 22, 5 squared is 25. So you get 1 minus 44 over 25, which is negative 19 over 25. Do you have 3 or 4 minutes for anything else?
I got like over here on 9C, I got like negative 28, and then I didn't know how to do it.
Okay. think you might have just done the wrong formula. So we have sine of 31 degrees cosine of 59 degrees plus cosine 31 degrees sine 59. So you're looking for a formula that's sine A cosine B plus cosine A sine B. So looking at your formula sheet, which formula is that? That's the sine of A plus B, because it's the plus in the middle. The cosine formula switches signs, but the sine does not. So then that's the sine of 31 plus 59. So that's sine of 90, which if you do your hand trick is 1.
That's what it is.
Those positives and negatives make a big difference. Anything else?
Okay, I'm gonna go back to a problem I did earlier because I didn't finish it.
Okay.
So, number 18, we had 1 plus cosine squared over sine,
Mm-hmm.
and then that's when you did the 1 over sine, and then you put 1 plus cosine. How?
Okay. I just separated this. So I said the top, there's really just like times 1 out there. So I separated out the 1 over sine times the 1 plus cosine squared. But if you don't like that, look at the other side. I don't have much room, but if I just change my cosecant to 1 over sine, then this is over 1, so that gives you the 1 plus cosine squared over sine theta. So if you didn't like how I did it, you could go work the other side and get there the same way. You're welcome. Anything else? If you do have any